Define an orthonormal system of the functions. Obtain the formal expansion of the function f of x equals to pi x minus x square. 0 is less than equal to x is less than equal to pi in the series of the orthonormal characteristics function phi n of the Sturm Liouville problem d square y over dx square plus lambda y equals to 0. Discuss the convergence of the formal expansion. Now solution: orthonormal system. If phi n where n equals to 1, 2, 3 and so on is an infinite set of the function defined on a is less than equal to of x is less than equal to of b, then the set of fn is a called an orthonormal set with respect to the weight function Rx on the interval a is less than equal to x is less than equal to of b. If first it is an orthonormal system with respect to the weight function Rx on the interval a is less than equal to of x is less than equal to of b, and second, every function of the system is normalized with respect to the weight function Rx on a is less than equal to of x is less than equal to of b. That is, the set fn is an orthonormal with respect to the weight function Rx on the interval a is less than equal to of x is less than equal to of b if integral a to b fmx into fnx into rx dx equals to 0 if m is not equal to n and equals to 1 for m equals to n. Second part, the given differential equation d square y over dx square plus lambda y equals to 0, equation 1, and y0 equals to 0 and y pi equals to 0, equation 2. We know that the Sturm Liouville problem consisting of the differential equation 1 and the condition 2 has the orthogonal characteristics function phi fn where fnx equals to cn in sin nx, n equals to 1, 2 and so on 0 is less than equal to x is less than equal to pi, and the cn n equals to 1, 2 and so on is a non-zero constant, and the orthogonal characteristics function fn of the problem under the condition are given by phi n x square root of 2 upon pi sin nx n equals to 1, 2 and 3 so on 0 is less than equal to of x is less than equal to of pi, equation 3. For the finding of the formal expansions, we now form the series sigma n varies from 1 to infinity cn into phi nx, equation 4, here for each n equals to 1, 2 and so 3 so on, cn integral a to b fx into phi nx into rx dx integral a to b of phi x minus x square into square root 2 upon pi sin nx into 1 dx square root of 2 upon pi integral 0 to pi x sin nx dx minus integral 0 to pi x square sin nx dx equals to square root of 2 upon pi upon n square sin nx minus pi x upon n cos nx, limit 0 to pi minus square root 2 upon pi into 2x upon n square sin nx plus 2 upon n cube cos nx minus x square upon n cos nx limit 0 to pi equals to square root of 2 upon pi into minus n square upon n cos nx minus n upon n cube cos nx minus pi square upon n cos n pi minus 2 upon n cube equals to square root of 2 upon pi into minus 2 upon n cube cos n pi plus 2 upon n cube equals to square root of 2 upon pi into 2 upon n cube into 1 minus cos of n pi equals to square root 2 upon pi into 4 upon n cube if n is odd n equals to 0 if n is even. Hence the series 4 becomes sigma n varies from 1 to infinity 8 upon pi into n cube into sin nx, or 8 upon pi sigma n varies from 1 to infinity sin 2n minus 1 into x upon 2n minus 1 cube. This is equation 5. We write as phi nx equals to pi minus x squared congruent to 8 upon pi sigma n varies from 1 to infinity sin 2n minus into x upon 2n minus 1 whole cube, where 0 is less than equal to of x is less than equal to of pi, so that the 5 is a formal expansion of the f in the terms of the orthonormal characteristics function phi n. Now first few terms of these expansions are 8 pi sin x upon 13 1 raised to power 3, 8 pi sin x upon 1 raised to power 3 plus sin 3x upon 3 raised to power 3 plus sin 5x upon 5 raised to power 3 plus so on. Now convergence of the formal expansion. For this we use the following theorem. If we have the Sturm Liouville problem consisting of the differential equation d over dx of px dy over dx plus qx plus lambda rx into y equals to 0 with the supplementary conditions a1 ya plus a2 y dash a equals to 0, b1 yb plus b2 y dash b equals to 0, where p and q and r are the real functions of such that p has a continuous derivative and q and r are the continuous, and px is greater than 0 and rx is greater than 0 for all the values of the x on a is less than equal to of x is less than equal to of b. Now further, if lambda n, where n equals to 1, 2 and so on, be the infinite set of the characteristics values arranged in a monotonic increasing sequence, lambda 1 is less than lambda 2 and less than lambda 3 and so on, less than lambda so on, phi n, where n varies from 1 to n 2 3 and so on, be the corresponding set of the orthonormal characteristics function, and f be a function which is a continuous on a is less than equal to of x is less than equal to of b has a piecewise continuous derivative f dash on a is less than equal to of x is less than equal to of b with the property that f of a is 0 if phi dash a equals to 0 and f of b equals to 0 if phi 1 b equals to phi 1 a equals to 0 and phi f of b equals to 0 and if phi 1 b equals to 0, then the series sigma n varies from 1 to infinity cn phi n, where cn equals to integral a to b f of x phi n x rx dx, where n equals to 1, 2 and so on, converges uniformly and absolutely to f on a is less than equal to of x is less than equal to of b. Now for the present problem, the coefficients p and q and r in the differential equation 1 satisfy the requirement of the stated theorem. Further, since f is a polynomial function, therefore it satisfies the requirement of the continuity and the piecewise continuous derivative on 0 is less than equal to of x is less than equal to of pi. Now stated theorem also requires that f of 0 equals to 0 if phi 1 0 equals to 0 and f pi equals to 0 if phi 1 pi equals to 0. These conditions are all fulfilled as pi 1 equals to square root 2 upon pi sine 0 equals to 0, f0 equals to 0, pi 1 pi equals to square root 2 upon pi sine pi equals to 0, f pi equals to pi square minus pi square equals to 0. Therefore all the conditions of the stated theorem satisfied, and hence we conclude that the series 5 is converges uniformly and absolutely to the pi x minus x square on 0 is less than equal to of x is less than equal to of pi, hence the result.